This is the story of an engine that shouldn't exist, built by a man who never earned an engineering degree and never even had a driver's license. Yet it went on to win the most grueling race on Earth, attracted $50 million from General Motors, and convinced some of the greatest automakers in history to rethink everything they knew about internal combustion. The Wankel rotary engine changed automotive engineering forever, and it almost died trying.
Felix Heinrich Wankel was born in 1902 in the Black Forest region of southern Germany. His father, a forestry official, was killed in World War I, leaving the family struggling financially. Wankel never attended university, never earned a formal engineering degree. But at 17 years old, he conceived the basic idea for a completely new type of internal combustion engine, one that would achieve intake, compression, combustion, and exhaust not through pistons hammering up and down, but through continuous rotation. In 1924, working out of a small laboratory he'd set up himself, Wankel began turning that teenage dream into reality. He received his first patent for a rotary engine concept in 1929, and a more refined patent in 1934. But it would take decades before the world saw a working version. In 1951, Wankel began working at NSU Motorenwerke, a German engineering firm. On February 1, 1957, the first running prototype of his rotary engine was successfully tested. On January 19, 1960, the rotary engine was presented for the first time to specialists and the press at the Deutsches Museum in Munich. So what made this engine so radical? The Wankel engine threw out the fundamental architecture that had defined internal combustion for over a century. Instead of pistons moving up and down in cylinders, it used a triangular rotor orbiting inside an oval-shaped housing. The rotor's crown gear meshes with a fixed gear at a 2:3 ratio, constantly forming three moving working chambers that cycle through intake, compression, combustion, and exhaust simultaneously. This eliminated the reciprocating mass of traditional pistons, which meant dramatically less vibration, remarkably smooth power delivery, and the ability to rev to extraordinary heights, theoretically up to 20,000 revolutions per minute. And the size was incredible. The 13B engine that powered the Mazda RX-7 displaced just 1.3 liters and occupied roughly 1 cubic foot of space. Yet it produced 232 horsepower. That's 178 horsepower per liter, a figure that was frankly absurd for its era. The engine weighed just 247 pounds. Compare that to any conventional engine producing similar power, and the difference is staggering. The automotive world took notice immediately. During the 1960s and 1970s, companies lined up to license the Wankel technology. Daimler-Benz signed on in 1961. General Motors followed in 1970, spending $50 million for the rights. Toyota licensed it in 1971. Alfa Romeo, Rolls-Royce, Porsche, Suzuki, they all wanted in. For a brief moment, it seemed like the rotary engine might replace the piston engine entirely, but one company committed to it more deeply than any other. In 1961, Mazda contracted with NSU to produce and develop the Wankel engine in Japan. Under the leadership of Kenichi Yamamoto, who would later become president and then chairman of the company, Mazda poured its identity into this unconventional power plant. In May 1967, the Cosmosport 110S rolled off the line as the world's first dual-rotor production car. Then came the RX-7 in 1978. This was the car that proved rotary engines belonged in the real world. Over 800,000 RX-7s were sold worldwide, with the first generation alone accounting for more than 470,000 units. It was nimble, it was light, and that screaming rotary engine gave it a character no piston car could match. But the rotary had enemies, and they were baked into its own design. The long, narrow combustion chambers created a high surface-to-volume ratio, which meant poor thermal efficiency, higher fuel consumption, and increased emissions of unburned hydrocarbons. On paper, a 1.3-liter engine should have delivered excellent fuel economy. In practice, it drank fuel like a V8. Oil consumption was another persistent issue, as was the tendency for apex seals to wear and leak. These flaws killed GM's rotary ambitions outright. Their Wankel engine proved dirtier than expected and less fuel efficient, and it cost about $250 more to produce than a conventional V8. The mid-engined rotary Corvette concept, a monstrous 8.4-liter quad-rotor engine making 420 horsepower, was quietly shelved when the 1973 oil crisis made fuel economy a national priority. But Mazda didn't quit. They had over 2 million rotary engines to their name and a stubborn, almost irrational commitment to the technology. And in 1991, that stubbornness paid off in the most spectacular way imaginable. On June 23, 1991, the Mazda 787B crossed the finish line at the 24 Hours of Le Mans, 2 laps ahead of the second-place Jaguar. Drivers Johnny Herbert, Volker Weidler, and Bertrand Gachot had just achieved something no one had done before, and no one has done since. As of 2026, it remains the only victory at Le Mans by a car not using a reciprocating piston engine. It was also the first victory by a Japanese manufacturer, a record that stood until Toyota's win in 2018. The 787B's R26B engine displaced 2.6 liters across 4 rotors and developed 700 horsepower at 9,000 RPM. Post-race inspections revealed the engine had lost just 2% of its power over 24 hours of continuous racing. Johnny Herbert called it silky smooth and bulletproof in terms of reliability. But the victory came at a cost. Herbert collapsed after exiting the car and had to be carried to the medical center. Weidler suffered severe tinnitus, likely caused by the engine's noise, which contributed to the end of his racing career. And here's where the story gets bittersweet. The following year, new FIA regulations mandated 3.5-liter naturally aspirated piston engines for top-tier Group C cars, effectively ending the Rotary's eligibility. Some called it a ban. The truth is more nuanced. It was a pre-planned regulation change. But the timing, coming just 1 year after the Rotary's greatest triumph, felt like the establishment slamming the door shut. The RX-8 arrived in 2003 with the Renesis engine, but sales peaked at just under 24,000 units in 2004 and steadily declined. By 2010, the car couldn't meet Euro 5 emissions standards and was pulled from Europe. Production ended in June 2012. The Rotary, it seemed, was finished, except Mazda still wouldn't let go. In January 2023, Mazda resumed mass production of vehicles with rotary engines for the first time in 11 years with the MX-30R EV. This time, the Rotary wasn't powering the wheels directly. An 830 cubic centimeter single-rotor engine serves as a range extender, charging a battery that feeds an electric motor. It's a clever reinvention, using the Rotary's compact size and smooth operation in exactly the role it's best suited for. Then there's the iconic SP concept, a dual-rotor rotary hybrid producing 365 horsepower at just 3,200 pounds. Mazda's design chief Masashi Nakayama confirmed it's headed for production, saying it was designed with real intent. The company's CTO sees it as a spiritual successor to the RX-7. On February 1, 2024, Mazda officially reinstated its RE development group, tasking it with evolving rotary engines for generator use and researching carbon-neutral fuels.
Felix Wankel died on October 9, 1988, 3 years before his engine conquered Le Mans. He never saw that victory, never drove a car in his life. But the engine he dreamed up as a teenager in the Black Forest went on to produce over 2 million units, win the world's greatest endurance race. The rotary engine didn't replace the piston. It did something arguably more important. But it proved there was another way. And in engineering, that question, that stubborn insistence that convention isn't the only answer, changes everything.